I am Kavyashri S. Assistant Professor, Department of EEE ATME CE, Mysuru. Dear students of ATME CE, I am delighted to welcome you all for today's session on Microcontrollers Lab. That is IPCC course and subject code is BEE403. Today we will going to analyze the data transfer. This contains the exchange or transfer of data between memories of internal and external as well, and within the microcontroller itself or between the microcontroller. Here we go with the program for block data movement transfer. So which is nothing but transfer data operation. The aim of this program is to transfer 8 byte of data from one external memory location, that is 8100H, to another external memory location, that is 8200H. These two are the addresses or container wherein you can save the data. These two are the containers. To execute this, Keil Microvision 3 platform is used. The steps or algorithm to write a program using assembly level languages are: initially we want to initialize some registers to hold a count data and also the source and destination addresses. Next, to get a data from source location into accumulator and then transferring to the destination location. Next, decrement the count register and repeat the step until the count is 0. So these are the steps which is very much important to write the program. So it is in essence the code perform a transfer data operation from one external memory location to another external memory location. So the data originally present at 8100H external memory location, after executing it is been moved to 8200H. So this process effectively exchanges the data, or this process effectively transfer the 8 byte of data from one memory location to another memory location. So before execution, so type the program in editorial window, then start the session by debugging it. In memory window, okay, open 8100H where save the data as 1 or whatever the number you want. So data 1 has been saved in first memory location 8100. Further on 8101 the data 2 will be saved. Further it is increased up to 8 byte of data has to be transferred. We required 8 external memory location, that is 8107, which contain a data of 8. After executing, so go to debug session, then run the session. After that 8 byte of data completely transferred to 8200H memory location. You can observe that whatever the data you have given in the first memory location of 8100H will be completely transferred to 8200. So likewise the other 8 data have been transferred, wherein the data 8 has been saved in 8207 memory locations. So further we shall move how to analyze the program in assembly level languages. So we required the number of 8 byte of data that has to be transferred, which means that 8 count or 8 times the data has to be transferred from one memory location to another memory location. Let us initialize the number 8 directly by using an immediate addressing mode called ASH to some register called R0. Next, take the first external memory location higher byte, so that is memory 1 higher byte, that is 81. Immediately it was transferred to R1 register. Next, another memory location, again it is a memory 2 higher byte 82, it is immediately transferred to R2 register. Next, so if you observe that these two are the external memories, so 81 and 82, so the common lower end is 0 0. Hence we initialize the another parameter, that is 0 0 is been transferred to R3 registers. Now my pointer has to show in first locations to store the data. Hence let us take 81 is been moved to DPH, where DPH is a data pointer higher byte. So get a first external memory location. Now the pointer is at 8100H location. So let us take R1 has been moved to DPH in the sense R3 is initially it is been saved with 00H. So that is been trapped to DPL. Now the pointer is showing in 8100H. So inside 8100H, whatever the data you have, that is being moved to some temporary register called accumulator. Okay, get the data from source memory to accumulator. Here, so initially we have saved in 8100H, the data is been saved 1. Now the accumulator is 1. Here X is being used because in order to move with an external memory location. Next, this accumulator value has to be transferred to 8200H memory location. Hence, call 82. 82 is being saved in R2 register and immediately transferred to DPH. Now the pointer is showing in 8200H memory locations. So whatever the content in accumulator, it is directly being transferred to 8200H memory location. So we can say that at is an the data has been moved to the container. Next, increment R3. So you are supposed to increment the R3 because 8100 is the first location. Next it has to move with 8101. Okay. So further this process has to repeat 8 times. Hence we use a opcode called DJNZ, where it is going to decrement the R0 register. If one transfer has been happened, the count will be reduced. So decrement the R0, then jump to wherever the label you have given. This is the label you have been given until this R0 becomes 0. So once R0 first transfer is done, means R0 is 7. Second transfer is done, R0 is 6. Likewise, until R0 is equal to 0, it is in the same loop. Then the next instruction will be executed once R0 become 0. So further, we move with the Keil software how to run the program. Let us take the program. So open the Keil software. The path created, how to create a Keil software is already been discussed. Then give, save, okay, then translate. Whatever you have written the code in hexa number will be transferred to binary. Then build target, then again rebuild it. You will be obtaining 0 errors and 0 warning. Then move to debug session, start and stop the debug session. Here there is a memory window. You are supposed to type a memory window as capital letter X colon 0x8100. This is the first memory location. So you can type the data here. So 8 data you can type. After that, so this is 8100 memory location, 8101, likewise 8107. So for 8107 memory location, you have entered the data as 08. So after that, you can go to this, debug it, run the session. Whatever the content in 8100H will completely move to the 8200H memory location. Then debug, stop. Thank you.